Good morning. Today I'm going to talk about, again, renal physiology. I'm going to talk about reabsorption, excretion, and secretion. Also, I will be talking about some important functions, endocrine functions of the kidneys and the acidification of urine. And in our last lecture, we talked about the mechanism of the formation of urine. And when we come back to our nephron, this is nephron. The whole of this picture is nephron. And blood flows from the heart into renal artery, and from renal artery into lobular arteries, and from lobular arteries it gets into the apparent arteriole, which divides into a series of small vessels, a network of vessels, and these vessels invaginate in the capsule called Bowman capsule. This is called the Bowman capsules. And from the Bowman capsules, they exit through the efferent arterioles. Now, when blood flows through these capillaries, glomerular capillaries, and glomerular capillaries are fenestrated. Their function is to filter plasma and other solids, plasma and molecules. All these are filtered through this capillary network. The rate of filtration is called glomerular filtration rate, and it is about 126 ml per minute. GFR, glomerular filtration rate, GFR, measures the normal function of the kidney. So it is the GFR that tells you your kidneys are functioning in a normal manner. The rate of filtration is inversely proportional to the diameter of the molecules filtered through the glomerular network. The molecules, which are 4 nanometer in diameter, are freely filtered. They enter into the Bowman capsule and into the tubules. Molecules which are greater than 8 nanometer in diameter do not pass through the pores easily. So, in other words, the rate of filtration is inversely proportional to the diameter of the molecules being filtered. Meaning, as the rate of filtration increases, the diameter of the molecules being filtered must decrease. There is another factor. The surface area of these capillaries are negatively charged, and any negatively charged molecules will find it difficult to be filtered through them, because negative charges repel one another. A lot of proteins are negatively charged. The cationic molecules are positively charged, and they can easily be filtered. And the anionic molecules find it difficult to be passed. All molecules smaller or equal to 4 in diameter will be freely filtered, except globulins, albumin, and fibrinogens. These are big molecules like hemoglobin. This molecule will not pass through the pores of the glomerular capillaries. Now, how do you measure glomerular filtration rate? It is simple. It is measured by injecting a substance called inulin. Inulin is a substance that is freely filtered, but it is not reabsorbed, secreted, or secreted. So the clearance of inulin is the indirect measure of the GFR. So the GFR clearance of inulin is using the fixed principle that says the amount of a substance given over a time unit, a given time, is divided by the arteriovenous difference. In this case, the clearance of inulin equals the urine concentration of inulin times urine flow of inulin divided by plasma concentration of inulin. So, supposing this value is, for example, this the concentration of a urine concentration of inulin is 12 milligram, and urine flow is 0.9, and plasma concentration of inulin equals 0.02. So when we substitute this, all this, we are going to get a number of like 126 ml per minute. So this is the glomerular filtration rate. Now, when substances are freely filtered, they pass through the proximal convoluted tubule, and from here, this is where reabsorption starts. Certain molecules are just passed from the lumen of the tubule into the interstitium by diffusion through their concentration gradients. Now, when we talk about the absorption of glucose, somewhere here, we take this, for example, this distal proximal convoluted tubules, and we take it here. Now, you have sodium in the lumen, and you need it back into the blood circulation. There are a lot of blood vessels here. There is an enzyme called SGLT here. This enzyme carries sodium into the tissue. It also carries glucose into the cell interior. And from this side, glucose will be taken by another enzyme called GLUT1. Sodium here will be taken out of the cell into the interstitium, by sodium potassium ATPase in exchange for potassium. Sodium out, normally 3, and 2 potassium into the interior, and water will also close the other solids. A lot of the other solids will come here into this tissue. Sodium, glucose into the interstitium, and the osmolarity of the interstitial cells will increase, and this will allow water to flow down its concentration gradient. That is how sodium and glucose are observed in the proximal tubule. The process of absorption just goes on until also the proximal tubule. And the solids are being taken out throughout the tubules. Another process that is very important is the secretions of the hydrogen ions. The cells called intercalated cells secretes hydrogen ions. Hydrogen ions. They secrete hydrogen ions, and these hydrogen ions must go into the tubular, must be secreted into the tubular urine, so that they are complex with another substances, so that they form acidic urine. This is called urine acidification. So water you have inside the cell, you have carbon dioxide coming from metabolism plus bicarbonate. This gives you a carbonic acid, and carbonic acid dissociates into bicarbonate, and hydrogen ions. Now, the hydrogen ions has to be secreted into the cell lumen in exchange. Hydrogen ion has to go this way in exchange for sodium. Sodium has to go into the cell. And from the cell, sodium will again be pumped out from the cell into the interstitium by sodium ATPase interstitium. Right. So carbon dioxide plus bicarbonate, they give you carbonic acid, a process catalyzed by an enzyme called carbonic anhydrase. Carbonic anhydrase. So you have this cell, this cell here, taken here in the proximal convoluted tubule. Inside here, inside this cell, you have carbon dioxide plus the water. It gives you carbonic acid. These carbonic acids again will dissociate into hydrogen ions plus bicarbonate. Now this one will go into the lumen. This is the lumen, lumen of the cell, lumen of the renal tubule, and this one will go into the lumen, and this one will go into the interstitium. For every one hydrogen secreted into the lumen, one bicarbonate and one sodium are reabsorbed. And now you have your load of hydrogen ions being secreted in the tube. Now these hydrogen ions has to be acidificated. The tube, so it has to combine with sodium bicarbonate. This one has to dissociate, take sodium out, and hydrogen ion will complex with this one, and it gives you di, and then again disodium phosphate by monosodium phosphate, and you have ammonia plus hydrogen ion, and you will have ammonium. So in the tube lumen, hydrogen ions will be taken in form of the complex compound, and this complex compound will decrease the pH up to 4.5. Another function of the kidney, apart from the regulation of our extracellular compartment, is the productions of certain hormone enzymes. And these enzymes are very important. The enzymes produced are, you have renal, you got renal, and we know how renal works. You have renal, you have 1,2 alpha 25 hydroxylase, and you have another substance called erythropoietin. Renin is produced by Makuur denser cells, and the function of this enzyme is to convert angiotensinogen, or sometimes called angiotensin-genase, is to convert angiotensin into angiotensin 1. And then angiotensin 1 will become angiotensin 2 in the lungs. Angiotensin 2 is converted by angiotensin converting enzyme in the lungs, and there it becomes active. And angiotensin 2 is the most potent protein ever found in the body, potent vasoconstrictor, and it plays a role in water absorption with the HDH. This one converts an enzyme, a hormone called calcitroid. This is the active form of vitamin D3, and this one goes into the kidneys and helps, into the intestine, and helps in the reabsorption of calcium. And this hormone is the erythropoietin. It goes into the bone marrow and helps our bone marrow produce RBCs. Imagine you have a problem with this hormone. What will happen? Imagine you have problems with this hormone. All these, in case of renal failure, all these functions will be impaired. So this is the message I want to share with you today. And thank you very much. Thank you. Yes.